Hello and welcome to our video on the distance between 2 points. Now this formula that I've got down here in a box is most useful when you are given 2 points. You might be given 2 points in the plane like this with the coordinates and you need to find the distance between the two. Or you might be given 2 points written like this, and 4, 10, just made 2 up for you, without a graph, but you've just been given the 2 coordinate points and you need to find the distance between those 2 points. So as a first step, you could graph them, but this formula that I'm about to show you would be really useful to help find the distance really easily. So I'm going to go over here to look at the graph that I provided, and I'm going to make up 2 points. That could be the 2 that we're looking for. I've made my dots really big just so you can clearly see them, but your dots don't need to be that large. So if we're trying to find this distance on the straight line between the 2 points, we're going to need to know a few things first. We're going to need to know the coordinate point. So this would be this is the y-axis, so this would be the y value of this point, and this would be the y value of this point. So I'm going to call this one y1 and this one y2. And you can see they line up with the 2 points. And I'm going to do the same for the x values. So this is the x-axis. This here would be the x value of this point. And here would be the x value of the second point. So this one is y1, so this one can be x1. And this one can be x2. You can see how they're linked to each other there. If you had the coordinate point written out, this one would be, this point as a coordinate would be written as, we always write x first, so it would be x2 comma y2, and this one here would be x1 comma y1. Actually, I've just decided I'll write that on the other side. X1 comma y1, and you notice the 2's go together and the 1's go together. You would never have an x1 and a y2. It doesn't work properly. Now what we're trying to do is find the distance between these 2 points here. So what I can do now is draw a triangle going across here and up here. And that would be a right angle triangle, and hopefully when you see a right angle triangle you are remembering our famous right angle triangle formula, which is a squared plus b squared equals c squared, Pythagoras' theorem. And what that can do for us is help us to find this third side. So the third side opposite the right angle is called the hypotenuse. You might recall this length is just going to be this number, take away this number. So let's put it in as x2 minus x1. Oops. This length here is going to be the y value y2 minus y1. And if we substitute these in, might give them a different color, so we could make this side A and this side B for our formula up here. So we get actually, I'm going to flick those around so the formula works okay. Doesn't matter which one's A and which one's B. This one will be A, this one will be B. So substituting in, we get x2 minus x1 squared for A squared, plus B squared, which is y2 minus y1 squared, and it will equal our C squared. And instead of putting c squared, I'm going to put d for the distance. And we've got these two plus, but it's d squared. We don't want to find this side squared, we want to find just d by itself. So to get rid of this squared, we need to do the opposite, which is square root this whole thing. Plus y2 minus y1 squared. Make sure your square root sign goes over all of it. And you get d by itself. So this distance here is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. That's a formula I've got right down here, and that's the one that you can use to help you find the distance between 2 points. I've got a worded problem here that I'd like you to pause the video now and have a go at working through yourself. Before I go through the solution with you together. Pause the video now. First step, I'd be looking at when I've got a problem like this, there's no graph, and I really enjoy having a graph so I can see what I'm actually thinking about. So I'm going to draw some axes. An offshore drilling platform in Bass Strait situated at 06, which can be here, and it's called D, so I can label it. Where 1 unit equals 5 kilometers, I'm going to highlight that because that's probably something I'll come back to later. Pipes for this oil drill come ashore at -6,1, which is M. And 3, -1, which is N. Assuming the pipelines are straight, how much shorter is DN than DM? That's a bad line, but you know what I mean. Okay, how much? So this one is supposed to be shorter than this one. Doesn't really look like it in my graph, but apparently it is. No big deal. I'm going to label each of the points so I can clearly see which one is which. Okay, and there we have it. Now, how much shorter is DN than DM? Useful also to highlight the question, so when we get to the end we can make sure we're actually answering that question. So we're going to have to work out how long the green line is, then we're going to have to work out how long the orange line is, and then find the difference between the two. For DN, so the length of DN will equal, so using my formula up here, distance between 2 points formula, I've just substituted the values in, so it's x2 minus x1, 3 take away 0. You could have chosen to go the opposite way, 0 take away 3. Doesn't matter which one's x1, which one's x2, as long as you keep the 1s and the 2s together. So it can be useful to put it here, 0, 6, 3, -1. This one is x1, y1, x2, y2, so you can quickly read it off. If you can read it off here, that's fine as well, but make sure you don't get them back to front and get yourself confused. Then we just need to solve this problem. So this is going to be square root of 3 squared plus -7 squared, which is square root of 9 plus 49. -7 squared makes positive 49, which is the square root of 58. And in your calculator, that is approximately 7.62 units. And this is where it will be useful to see 1 unit is equal to 5 kilometers. So we need to times this by 5 to get the length of the pipe is 38.08 kilometres approximately. So that's dn. Now we need to do the same for dm. I've put my 2 coordinate points, listed them out here, listed them as x1, y1 and x2, y2, so I know which ones are which, and now I'm just going to substitute them into the formula. So I've substituted the first line in. Yours might have been opposite, but as long as you get the same answer at the end, doesn't matter which one is listed as 1, which one is listed as 2. So we get negative 6 squared plus negative 5 squared. Which is 36 plus 25, which equals square root of 61 into your calculator is approximately 7.81 units. We need to multiply that by 5 again to get the distance 39.05 kilometres. Some people might be tempted to stop here and say, here's my 2 answers, finished, done. And this is why it was really important to highlight what the question actually is and remind yourself. So the question is, how much shorter is one than the other? So we just need to do a simple 39.05 take away 38.08 equals 0.97. Try that 0 again. So it doesn't look like a 6 kilometres. And it doesn't say our answer has to be in kilometres, it just says how much shorter. So I'm going to put that into metres because it looks nicer in metres. 970 metres. Final answer, it can be useful when you're doing all this working to put your final answer inside a box. And you could even, as this is a worded problem, you could write it out in words. dn is 970 metres shorter than dm. Thanks for watching the video.